Welcome to SN Physics. Today we will solve some problems on Biot law. Before going to solving the problems, I am recapitulating some formulae just like a straight wire in which B is equal to mu 0 by 4 pi I by r sin theta 1 plus sin theta 2. For infinite wire, this theta 2 becomes 90 degree as well as theta 1 becomes 90 degree, giving B equal to like this. For semi-infinite wire, this theta 1 goes to 0 and theta 1 goes to 90 degree, giving B is equal to mu 0 I by 4 pi r. Similarly, if the wire is something like that and the point P is far apart in this way, then theta 1 is negative, theta 2 is negative. But theta 1 is negative is already taken into account in this formula, but theta 2 was positive in this formula, which is negative here. So putting theta 2 is equal to negative in formula 1, we get minus sin theta 2. Similarly, if this point P goes to A, then as P goes to A, it becomes 90 degree. So theta 1 is equal to 90 degree and theta 2 is similarly 90 degree. For finite wire, this theta 2 is theta and theta 1 becomes 0. So we are with B equal to mu 0 I by 4 pi r sin theta. In all this discussion, we have taken I in this direction, R in this direction, dl in this direction, R in this direction. So dl cross R is a screw rotating which is proceeding away from you. So it is a cross. All these are cross. In semicircular arc, this theta is pi. So B equal to mu 0 I by 4r. Or in this arc, circular arc and semicircular arc, current is in this direction. So it is rotating in this fashion. This screw is going away from you. Again, the field is denoted by cross. Apart from all this circular arc or straight line, force on a current carrying conductor is given by this. This is basically low range force. dq is the charge which is propagating with a velocity v in the direction of v. Then dq velocity is equal to dl dt. So we take dq dt apart. So this is current I and dl cross b. If dl and b is perpendicular to each other, then theta equal to 90 degree. Then integrating df, we get f equal to bil. So force on any charged particle or force due to a current is given by f equal to bil. We will now use all these formulae in the preceding coming examples. So you better take a screenshot of these tables. That will be very helpful to you. Thank you. We will now apply formula 1 and 7 to solve this problem, which is a current carrying coil. The direction of current is shown in the figure and this angle is 60 degree. So these are, in this figure R and R is like this. So this angle is 30 degree and this angle is 30 degree. So theta 1 is 30 degree and theta 2 is 30 degree. So B is equal to mu 0 I by 4 pi x sin 30 degree plus sin 30 degree. Now what is x? X divided by r is equal to cos 30 degree and which is root 3 by 2. So x equal to root 3 r by 2. So mu 0 I divided by 4 pi x is root 3 r, then it is 2, and sin 30 plus sin 30 is 0.5 plus 0.5, leaving b equal to 2 mu 0 I divided by 2 root 3 r. For this circular arc, the current is flowing in this direction and current is flowing in this direction. So in the linear part, B is like this, say it is B1 and it is away from mu, and for the arc portion we are using this formula. Then theta is equal to, this is 2 pi minus pi by 3, this angle is pi by 3, so this angle is 2 pi minus pi by 3, so it is pi by 3. So B is equal to mu 0 I by 2r into theta means pi by 3 and it is 2 pi. leaving pi cancels out, mu 0 I phi divided by 12 r. So it is B2. So the net field, this field is also away from you. So this B1 and B2 will give net field B is equal to B1 and B1 plus B2, because these two fields B1 and B2 are both away from you. So their sum gives us. This problem is asked to find out the magnetic induction or intensity at center of the coil O, this O. Now look, this problem can be treated in three parts. Say part 1, this is the arc, and this part 3. In part 1, the point O is on the extension of the line. O being, this point O being on the line of current carrying wire, B1 is equal to 0 according to formula 5. Next, this is the arc, which makes an angle theta. This total angle is 2 pi. This is pi by 2. So the rest of the angle is 2 pi minus pi by 2. That is 3 pi by 2. If we put this 3 pi by 2 in this formula, which is the formula for arc, circular arc, formula 7. So we get B2 equal to this. The direction, the finger is going in this direction, so magnetic field is towards you. If we apply the formula dl cross r, that also gives you dl in this direction, dr in this direction. So dl cross r is rotating in this direction, giving the direction of the screw towards you, so field is towards you, which is denoted by a dot. The last portion is the 3, which is nothing but a semi-infinite wire. And the formula for semi-infinite wire is mu 0 I by 4 pi r, which is formula 3. So the net field, the direction of B3 is also, this is R, this is dl cross R, again towards you. So net field is sum of these three fields, so B equal to this is. Then we actually find, we have already found out the magnetic induction or intensity at the point O as this, and the direction is towards you. It is asked to find the magnetic induction at center O. This is the semicircle, this is the quarter circle. In case of semicircle, upper semicircle, the direction of current is anticlockwise. So if we put our finger in this direction, so magnetic field is towards you, denoted by dot. In the lower semicircle, direction is this, so it is away from you. Now, this is, being a semicircle, we are using formula 8, which is B equal to mu 0 I by 4 r. For the larger circle, semicircle it is R2, and the lower circle it is R1. So, net field B2 minus B1 is equal to this. But R2 being greater than R1, B1 is less than B2, B2 being large, B2 minus B1 is the net field. The contribution from the current AB and CD is 0 because the point O is on the AB and CD. So we are using formula 5, which says if the point is on the current carrying wire, the B is equal to 0. So net field is equal to this, and the direction of B2 is being away from you, net field is also away from you as B2 is greater than B1. In case of quarter cycle, the formula B is equal to mu 0 I by 8r. So for the larger circle it is 8b, and the smaller circle it is mu 0 I by 8a. B greater than A, so B1 less than B2, net field B is equal to mu 0 I by 8, 1 by A minus 1 by B. And the direction is here opposite because this is clockwise, so it is away from you. This is anti-clockwise, so it is towards you. So this field is towards you, as because this field is greater, and the contribution from the linear portion O being on the line of the coil, and this is also on the line of the current carrying coil, so the net field B is equal to this. Problem also, we have to find the magnetic induction at center O. The direction of current in this part is in this direction, the direction is same, but dl being in this direction and r being in this direction, dl cross r is away from you. But in this case, dl is in this direction, r is in this direction, so it is rotating in this fashion, it is towards you. So these two contribution cancels out. We are left with a semicircle. The formula for the semicircle will be equal to mu 0 I by 4r using formula 8, but the direction. Here, dr is in this direction, dr is in this direction, blue chalk, and this is the direction of dl. So dl cross r, this is rotating in this fashion, going away from you. So this is towards the whiteboard. So the net direction of the B is cross. This is the magnetic field at the center O. In this case, this is a semi-infinite wire, this is another semi-infinite wire. So the direction of the current is this, dl, this is r. So dl cross r going in this fashion is away from you. In this case also, dl is in this direction, r is in this direction, dl cross r is away from you. So the net contribution is 2 times mu 0 I by 4 pi r. And contribution due to the whole circle is mu 0 I by 2r, which is dl is in this direction, dr is in this direction. So dl cross r is anticlockwise fashion towards you. So the net field B2 minus B1 is equal to this. If magnetic induction is B at the center of a single turn current carrying circular loop, if this is the single turn circular loop, then if this wire is converted to N turn, this wire is now compressed to N turn, then it looks like this. Then if L is the length of the wire in first case, this is the first case, L is equal to 2 pi R1 and R1 is equal to L by 2 pi. Then the magnetic field at the center is B equal to mu 0 I by 2 R1, that is mu 0 I by 2 L by 2 pi, that is mu 0 I pi by L. Now this wire is wound in such a fashion that L becomes 2 pi R2 into N. The radius is decreased, so that 2 pi R2 N is L. So R2 is equal to now L by 2 pi N. So in second case, B is equal to mu 0. Note in this case, there are N turns, so it is mu 0 Ni by R2. So if it is B dashed, say, then B dashed equal to mu 0 Ni by R2 means L by 2 pi N square. So comparing these two, we get there is a 2 R2, so it is 2 giving this. Now if we compare B dash and B, we say that it is nothing but N square D. In this problem, we have to find out the force on a square loop of side A as shown in the figure near an infinite straight wire carrying a current I also. The force is I dl cross B according to formula 10 and F equal to BIA, integration dl being A, and the angle between dl and B being 90 degrees, sin 90 degrees is 1, then it is BIA. Now at the bottom, the magnetic field due to this current I is mu 0 I by 2 pi S, S being the distance, the formula 2. The direction is like this. S being in this direction, dl being in this direction, dl cross B anti-clockwise fashion towards you is the dot. Now force is dl cross B. In this case, current dl in this way is in this direction and B is in this direction. So dl cross B is going up. So the net force is up. B top at this position, we have to replace S by S plus A, and the F2 is this. But the direction of current being opposite, it is downward. So the net force is F1 minus F2, and it is, since S plus A is greater, this force is small, so net force will be in the upward direction. Now, what about the two perpendicular sides? In this direction, dl is in this direction, B is in this direction, so dl cross B is in this direction. But in this direction, dl is in this direction, B is in this direction, so it is anti-clockwise fashion. So they are opposite to each other and cancel out. So net contribution is nothing but this is, and it is up. The net force is upward. This is a problem from David Griffith. In third edition, the number is 5.10b, and my previous problem was 5.10e. In the previous problem, there was a rectangular loop. Here it is a triangular loop. So I have placed x-axis along the infinite current where this is my y-axis, this is z-axis. This equilateral triangle, so this angle is 60 degree. So this angle is also 60 degree. So if this coordinate is x comma y, this y by x is tan 60 and y equal to root 3x. Moreover, this is x and this is s. Then again x equal to s by root 3. S by x equal to tan 60 degree and x equal to s by root 3. So this point is at s by root 3. Now, force on the bottom is same as the previous problem, which is mu 0 I square a by 2 pi s, which is in the upward direction, which is already shown in my previous problem. And B, what is the direction of B? B is, this is your R, S is the direction of R, this is the direction of current, then dl cross B, this is towards this direction, this is the direction of Z, so it is along Z cap. So df left, there is a force on the left hand side of the triangle is I dl cross B, dl may be written in this fashion, cross B, so we are left with this. In the right side, the current is in this direction, so dl is in this direction. So if we resolve the dl in dx and dy, dy is negative, so dy is negative. After the cross product is the result, and df is equal to, this is minus dy x cap, but in the left it is plus dy into x cap. When we add these two cancels out, left with net df equal to this. Now, y is equal to root 3x. If we put root 3x in this case, then our integration will be this and this. Now, what is the limit? Limit is that in this point x equal to s by root 3. So our lower limit is s by root 3. And for the upper limit, this part, this is equal to s, for this part, s by root 3 plus a by 2, this is a by 2. So the upper limit is s by root 3 plus a by 2. As we have added this portion and this portion, so if we integrate from this point to this point, we get total f. Here, after putting the limit s by root 3 and it is s by root 3 plus a by 2, we get the final result as this, and the net field is upward direction. In the previous case, the F1, that was also in the upward direction. So the net field in the upward direction is something like this.